This week, what we're going to be covering is the last of Newton's laws of force and motion. And along with that is another calculation that you're going to have to do as well. So let's get into it then. So hopefully you have this document at this point. So number one says Newton's third law. So the definition to it, one object exerts a force. Force is the first blank on the second object. The second one exerts a force on the first that is equal in size, but it's opposite in direction. So since they're equal in size and opposite in direction, that kind of leads to number two, and maybe you've heard this before. It's kind of like the nickname of what Newton's law is. It's the action-reaction law. So it says for every action, there is an equal and opposite reaction. And in a little bit, we're going to get to some examples here as well that'll hopefully make some sense to you. So number three, action-reaction forces always act on different objects. So even though the forces may be equal, they cannot be balanced. Remember, anything that's balanced forces are forces that there's no movement that takes place. So action-reaction forces have to be unbalanced forces because obviously there's movement. So some examples to think about then. I have down here swimming. So if you think about whenever you're swimming through the water, you're reaching and pulling. You're reaching and pulling. Well, think about your hand. As you push against the water in one direction, normally backwards, your body is propelled in the opposite direction. So you've got an action force, the swim stroke, and the reaction is you moving forward through the water. Another example you can think about is a rocket ship. We're going to get to astronomy here shortly. So you think about the thrust for rockets is downward. So when the engines ignite, all that power of the rocket basically is in a downward direction. That's the action. The reaction is the fact that the rocket then travels upward into space, basically. So that's just two different examples to think about. Obviously, there's many examples of Newton's third law that you could probably come up with. All right, so the next calculation that you are going to have to do, number four, is the word momentum. Momentum is a property of any moving object that equals its mass times velocity. So if you want to know how to spell it, here's the spelling of it right here. So because we already used m for mass, they usually use the Latin spelling for momentum. So when you look at the formula for momentum, capital letter P. P is momentum, and it's simply equal to mass that's in kilograms times, remember what V is? V is velocity. And velocity would be in meters per second then. Momentum does not have its own unique units like force did, was the Newton. Momentum is just what you multiply by what. So it's kilogram times the meter per second. That's the units for momentum. So when you do the practice problems, which are part of this section's assignments, just make sure you include this as the units. And again, all you're doing is you're multiplying two things together. So pretty easy formula. All right, number seven then is a law. It's called the law of conservation of momentum. Law of conservation of momentum. That's the total amount of momentum of a group of objects does not change unless the outside force acts on the object. Now, when we talk about groups of objects, that kind of leads to number 8. Momentum can be transferred from one object to another. You do lots of different sporting events that depend upon this transfer of momentum. So, for instance, you swing a baseball bat to hit the ball. So your momentum that you apply to that bat is transferred to the ball, and that's hopefully what hits it into the outfield or possibly even a home run. Same thing with a tennis racket. How are you able to get the tennis ball, back over the net to your opponents? Well, you're swinging the racket. That action of swinging, you're hitting the ball, and that's transferring momentum to that object, getting it to travel in the opposite direction. Now, when it comes to groups of objects, there are certain activities we do that rely on this transfer. So, for instance, if you ever played pool or billiards, you hit that ball, cue ball into the rack of balls. Basically, where you're trying to bust them up and then get the highs and lows into the pockets, depending upon which one you get in first. So you're transferring that momentum to that group of objects. Same thing for bowling. Think about a bowling activity. That's usually the activity I do with my kids in class. Is I kind of bring in the bowling pins and the rubber balls from gym class, and I have a competition between them and myself. And I tell them at the beginning that I give them 2 shots per frame as a class, and each kid gets a different shot. So the second kid gets to pick up a spare if the first kid didn't get a strike. And me, they're playing against me, the teacher, and I only get 1 shot per frame. So they're all excited about this because obviously 2 shots to 1 shot, they think they get a much better deal on this and are going to win the competition. But what they don't realize is when the game starts, I get to use the 1 regular bowling ball from the phys ed class, which is that big, heavy rubber ball I'm sure you've used before. And they've got to use these tiny Nerf balls, basically, that are really lightweight. Even though they get 2 shots, because they can't generate as much momentum because there's not as much mass with their Nerf balls, there's like no way they can win the competition, basically. So I win it all the time. And of course, they get all upset because they don't think it's fair. But hey, I gave them 2 shots to 1. You would think that they would have the advantage. But really, when it comes to momentum, you want to have something that's more massive and a greater velocity to generate more momentum then. All right, so you can work on the 2 assignments with this section. And there's also a test or quiz with this section. So you definitely want to review these notes along with Newton's other laws as well. Force calculation, that's all part of this test that's part of this section. So good luck, and that's the end of this one.